Hello, everyone. A very good evening to all of you from India. My name is Vaibhav, and I'm from Team Eduonix. And guys, I'll be the co-host for the today's session. So, guys, can you just let me know whether I'm audible or not? And is my screen visible to you all? Hi, Chaitra. Can you just confirm me? Okay, okay. Thank you so much. I see lots of yeses coming along. Thanks a lot, guys. So, guys, where are you all from? Like, which country, which city? Please let me know in the chat box, guys. Also, do mention if you are a student, if you are working. For example, guys, you can type your country's name, comma. If you are working, you can type working. I'll just like I have done. Darshan is from India. I see lots of people are from India. Germany. Rajdeep is from Germany. Very nice. Okay, so I see we have a global audience over here. Singapore. Francis is from Singapore. Echner is from Canada. Okay, nice. France. Okay. So yeah, guys, thank you so much for coming over for this lovely session on introduction to blockchain technologies. So guys, our instructor today is Mr. Ihab McShea. So I would like to talk about Mr. Ihab. So he's a theoretical computer science guys and a pure mathematician. So his areas of research primarily revolves around the theory of computation, mathematical cryptography, mathematical biology. Guys, he's a senior software engineer with over 10 years of professional experience. He is also skilled in developing robust backend systems, front-end user experiences, and performant mobile applications, guys. Uh, Guys, also, he has done years of research in blockchain technology, automata theory, compiler construction, and there are lots of other topics, guys. Guys, he has also worked as a CTO and a tech lead for several popular startups in Egypt. So yeah, there are a lot of things that you can learn from him, and yeah, he'll be helping us with our today's session. So, okay. So as I can see, we have almost 120 participants, which is very nice. Guys, I forgot to mention that we are also live on our YouTube channel. Okay. And we have quite a participants joining in from there as well. Also, guys, I would like to inform you that the PPT which our instructor is going to share or which is he's going to use and the recording of this session, both the things will be available to you on your Eduonix dashboard by let's say by end of the Monday or latest by the Tuesday, guys. So no need to worry about the PPT and the recordings. Okay. So nice to see we have almost guys 130 participants. So while we are waiting, guys, I would like to inform you about something interesting. So Eduonix is coming up, guys, with some really cool offer during this session. So this offer is just in a way to help you guys in your professional career, but and to help you guys to become an expert in the blockchain technologies. But guys, there's one condition with this. So this offer is only be gonna available for those who are attending this session. So guys, it's my humble request to you all to stay with us till the end. And yeah, so now guys, without taking much of your time, as I can see that our instructor has also joined in. So, and we have almost 130 participants. So I think, Ihab, if you are ready, then I will just stop sharing my screen and we can take forward this session from here. You can.
All right. So hi everyone. Thank you so much for being here today, and I'll start sharing my screen and let's get started. Okay. Hopefully everyone can see my screen well. So today we're going to talk a lot about very interesting things in the blockchain. We're going to talk about the concept of blockchain. We are going to talk about the history of blockchain. Where exactly did the blockchain originate? What were the workings that led us to what we have here today? And we're gonna be talking about the technology, what makes the blockchain work, why does it work, and we're going to talk about cryptonomics. I just want to stop here and ask if someone actually heard of the term cryptonomics before, or actually blockchain. This session is going to be very interactive. I'm gonna I would love you guys to interact, ask questions. There will be a QA section at the end of today, but smaller questions, things that would need like immediate clarification about something that we're talking about would actually be appreciated. There, no problem there. But yeah, all right. So we're going to talk about decentralized applications, and this is the area I love the most because I have like the most experience in both cryptonomics and decentralized applications. And all right, so the concept of blockchain had been around for a really, really long time, maybe dating back to the 80s. Um, and so many people tried to come up with ideas, try to invent something interesting until the first notable your first notable implementation or idea or theory was in 1991. A group of scientists decided that they would have something like a digital notary of digital documents. So you have documents and you want to make sure that no one tampers with those documents, so you timestamp them. That was the original idea, and this was back in 1991 by Stuart Haber and W. Scott Stornado. And then, people started getting more and more interested in that idea. And then a very notable computer scientist called Nick Szabo, by the way, he is really, really one of the most important people behind Bitcoin. He did not, there's no proof that he developed Bitcoin, but the work that he did was heavily used in the original implementation by Nakamoto, Satoshi Nakamoto in the of Bitcoin. So anyway, he came up with an idea called BitGold. BitGold was never actually implemented. So technically, when people claim the first digital currency, it really isn't, because no one actually implemented it. And then someone came along and tried to make the idea better. And how can they make it better? They try to use cryptography in blockchain, and that was what Stefan Kant did in 2000. And then a group of scientists back in 2008 came up with an idea, and they were really, really smart. And we're going to know why, because technically the implementation of Bitcoin is really, it's very referenced in other implementations, whether in Ethereum or in any other yeah. All right, so someone raised the hand. Okay, right. You can actually speak because I have a problem actually navigating. Not sure why. Okay. So 1 second. Let me see. Yeah. Someone's saying audio is not working. So can you guys hear me well? I want to know if you guys can all hear me fine. All right. Okay. All right. Okay, so someone raised a hand earlier. I just want to know if something was up. All right, okay. All right, great. So let's go back and continue our session. Right. So, after that, Nakamoto actually used a lot of ideas because, proof of work, which is something we're going to talk about heavily today, was actually something invented back in 1992. It was an idea that people used to make it computationally expensive to send spam emails. All right. And after that, it was actually called proof of work back in 1997, and no one virtually used it until Satoshi Nakamoto found a really brilliant idea and incorporated it into Bitcoin. So anyway, before we get serious, I actually wanna just break the ice a little bit. So actually want to know if you guys have heard of Dogecoin. Yeah, so yeah, all right. Yeah, of course, of course. So many people know about Dogecoin. So, this slide actually to the moon. Yes, yeah. All right. Dogecoin started as a joke coin back in 2013. Yeah, it was invented by two very interesting software engineers. One was working for IBM and the other was working for Adobe, yeah. And they were just experimenting because the idea is very interesting. If you're a developer and you find something like blockchain, you want to experiment with it. And so they made it and they called it Dogecoin because, it was not really intended to be very serious at first. It's the fun and friendly internet currency. It's open source, which means people who have experience can actually contribute and make it better. And actually, you can see the source code as well. It cannot be mined. One of the very interesting features about it, because again, it's a joke meme. It cannot be mined using those very expensive mining processors. It can only be mined by computers. The block time in Dogecoin is 1 minute. Again, I know that this is something. Yeah, I mean, cloud technology is still a computer. If you go to AWS or Google Cloud, you're basically renting a computer. It could be a very basic computer, really more basic than yours, or it could be more advanced. So, but there are specific CPUs. They're called ASICs. They are built so that they can harness their entire energy just to mine. There are mining farms, and we're going to talk about all of this. I'm not here to make you guys, hate mining, but anyway. So as you can see, there is a photo of Elon Musk down there, and I'm pretty sure everyone here knows Elon Musk. Yeah, so the reason why he's in this slide is just because he is the one who created the hype for Dogecoin. He is creating such big hype for Dogecoin, and its price is climbing up so fast because of Elon Musk. Anyway, off to the serious stuff. Okay, so we have had our fun. And I actually want to ask, like, does anyone here, or is anyone here familiar with the term? Yeah, he is very influential in crypto. Is anyone here actually very familiar, or at least somewhat familiar with the concept of blockchain? Not just, blockchain, but like the concept itself. All right, that's good. So a few people here know this. Yeah, that's awesome. There's someone here who is R3 Corda certified. That's so great. I worked with Corda 2 years ago, as in like tempered with it, not worked for the company. But yeah, all right. So it's not complicated. Actually, the concept of blockchain is very simple. It's very, very simple. And that's actually kind of why it's it's so powerful. Anyway, so the blockchain is just basically a technology that stores data for transactions, any kind of data, but it has to store it in a way that is chained, ordered, and somehow related, or not somehow, we'll explain how it is related. Okay, so this is the blockchain. So this is the chain of the yeah, this session will be recorded. Yeah, it is also being live streamed on YouTube. Yeah, okay, so yes, guys, the session is recorded. Yeah, thank you. So anyway, it was we said this is the chain part of the blockchain. Then we have something called distributed ledger. So I'm gonna break it into very small terms here, and let's say that, you know, before we talk about technology, let's say that we are all here. Let's suppose that we're all nodes or computers. Let's pretend that we're not people anymore. In order for us to be a distributed ledger, then there has to be a way for us to agree on the data we all store, which means, like, because again, we said we are computers, we're not humans. So let's suppose that I have a piece of data, like let's say, you know, okay, let's make it very simple. All of us have each other's names. In order for it to be called distributed ledger, that means that we're all synchronized. We have the same exact data. And by synchronized, uh, I mean like if I change my name, it has to be changed on your computer as well. If another computer gets here and its name is registered in in our database, it has to be stored in all other databases. And this is actually a simple but very complicated concept. We could say like, oh, all right, okay, yeah. So we're basically just storing the same data. But here's the thing: how can we make sure that? Okay, so someone raised the hand. Uh, okay, so until you type out the question, I'm gonna continue my sentence. So basically, you know, in order for us to be called distributed ledger, we have to find a way to actually agree on something. But before all of that, we said that blockchain is a series of blocks. What you see in front of you, what we see in front of you is basically a blockchain. So here's what's happening. Each one of those blocks has a bunch of data. This data could be transactions, it could be words. Who cares? That's not the point. The point here is that each, each one of those blocks is chained to the one previous to it. And this way that is it's chained, it's kind of like, I'm saying like, see this block, this block continues right after the previous block. So this is the way we chain those blocks. So you might be wondering, what exactly is a hash? So I'm gonna assume, or I'm gonna ask also. I think a big percentage of you have actually some way of a computer science degree or a technology background. I saw this earlier. So many people, yeah, I think were either interested in tech or maybe working as developers. So anyway, yeah, hash is related to encoding. So in very technical terms, a hash is basically a function. If you don't understand what a function is, it's just basically like a computer. Let's say it's a computer program. You give it something, it has to give you the same hash. It maps it. So yes, it is a cipher of text. Yes. All right. So yes, it is encrypted data. And basically what happens is that when I give it, and this is actually really crucial for blockchain, or at least in the popular implementations. Okay, so what we do is we say we've had these 20 transactions, and we have some metadata or whatever, we hash them, and we end up with a hash. The importance of this hash is, you might be saying, okay, so yeah, data is stored in a block. Who cares? We can store data in a database and someone can change them. And this is where the hash comes into play. Yes. So the hash comes into play because if I change the data, if I change the data in the block, the hash will change. All right. How does this play into the whole blockchain idea? See, I'm saying that each block has to reference the hash of the previous block. So in a way, the block, each block references the data in the previous block. It doesn't store it. The previous block stores its data, but it just references it. So yeah. So if you change this hash, then the chain breaks. All right. Okay, so hashing is cool. It's great. It's a way to make things more complicated so you can change the data, but it's not really enough. You have to actually start using something else. But before that, we actually, you might be wondering how exactly does a blockchain work from the view of a user. Okay, so basically, let's say yes, a block is like a linked list. Great, guys. Yes. Yeah, it is exactly like a linked list. It actually, yeah, some people will yell at me for saying that it is a linked list. Well, Merkle tree is, well, technically, yeah, technically. But okay, so this is actually a whole other thing. We're gonna talk. We might talk about Merkle trees at the end, but yeah. So you can say that it's a linked list because now we're not really too deeply technical into what blockchains are. We're just trying to establish what a blockchain is to everyone. So anyway, let's suppose that I want to make a transaction. I want to pay someone. Let's call him John. I want to pay him some money. So I request a transaction. I say, okay, so here's my private key. I'm signing this transaction, and the transaction is going to the public address of John. Uh, and uh, and so I send this to the network of nodes, okay, and they somehow will get into that, somehow communicate it between each other, they synchronize it, someone mines it into a block. We'll talk in details about this in a second, and then the transaction gets verified, okay, and when it gets verified, it is broadcast into the network by being put in a block, and this block is basically in the chain of the blockchain, and then the transaction is completed. So this is from the point of view of an end user or a customer. So anyway, we talked earlier about hashes, and we said that the hash is basically the fingerprint of the block. It says what's in the block, but not really says it. It's a fingerprint for it. But is that really enough to ensure the security of the blockchain? Because the security of the blockchain is really complicated. Because anyone can change the data. I'm not talking about blockchains. I'm just talking in general. If we're storing the data on all computers, one makes us so sure that the data will not get compromised somehow. So this is where the concept of consensus comes into play. And if you're not familiar with the concept of consensus, it just means that we all agree on something. So this is the definition that's not technical. The technical one is very close to it. But so the blockchain has a state. And by the state, I mean the balances, the transactions, the blocks, and all of that. How can we, a bunch of strangers, because this is what a blockchain is. It's especially if it's public. I will assume it's public for now. What makes us sure of the information? Like if I tell you something, why would you absolutely be certain that it is true, right? So there has to be a mathematical or algorithmic way an algorithmic way to actually stop this. Okay, so yes, you can change data on your local node, but there would be a way on the network that this would not actually affect anyone. And this is the consensus algorithm. Again, we have a network of peers. They don't know each other. Yes, so they don't know each other, and they are storing data. They are a distributed ledger. They have to come to consensus to the state of the blockchain so they can actually function properly. And so, earlier we talked about proof of work, and we said the proof of work really came in in the early 90s, and then it got its name in 97, and was basically for emails. So Satoshi Nakamoto, he used this very cleverly, but at the same time, it does have its disadvantages. We'll get into that. But proof of work is basically, remember the blocks we talked about earlier? Remember when we said each block references the hash of the previous block? So proof of work is a way so that only one person, or one node, or now it's no longer just one person or one node, they will actually mint or mine the new block. So the transactions sit in a block. The block is in the network, but it's not really in the blockchain. So we need someone to actually do some work, and this is why it's called proof of work, so that this block will be mined. So how do we do this? We ask people in the network to solve a mathematical problem. What is the mathematical problem? Remember when we talked about hashes and we said you take this data and you hash it so it maps into this? So proof of work essentially asks you to do something. Okay, this is the concept of proof of work. And obviously this would need computational power from your CPU, from your GPU, and will obviously cost you electricity. And then you get rewarded when you actually solve this. So anyway, an implementation or an example of this would be like, okay, so see the hash of the previous block. I want you to take it and generate a new hash. I will give you a nonce, or you get a nonce. An nonce is just, something random. Yeah. So I want you to generate a new hash that has 6 zeros in front of it, which is, by the way, it's not easy because you don't know exactly how you're going to generate this, okay? So yeah, it does need a very high hash rate. So anyway, you might be thinking, all right, so computers are getting progressively better. So okay, so how are we going to solve this? Because maybe at one day, people will actually, have really supercomputers that would mine, and this problem would, like, the blocks would be, mined instantly. And why do we actually need blocks to be not mined instantly? Why does it take time? Why did Satoshi Nakamoto make it such that mining is not very easy, or not somewhat easy, and not extremely hard? Here's why. Because this is again, this is a network. There's a question that you might be wondering: how does one enter the network? And one enters the network is basically, he connects to the network, he downloads some kind of software, and then he asks the network for a copy of it. And yes, there are bootstrap nodes, but that's not the point. You have to download the entire blockchain onto your computer so that you can be a part of the network, okay? So, you might be wondering, who should I go to ask for this copy of the blockchain? Satoshi Nakamoto says the longest chain is the most valid one. Here is a huge disaster that would actually, if there was no mining difficulty, I can just mine blocks on my own local node and just start broadcasting it to new nodes. But then here's the thing. This is where hashes and proof of work come into play. Remember earlier we said that if you change a piece of data in the block, the entire block, the hash would become different, thus breaking the chain. So the block in the middle is not connected to the, it's not connected to anything behind it. And if you change a block, you have to actually change all other blocks after it. And this takes, like, mining actually takes so much power. Imagine trying to corrupt the network. It would just take a crazy amount of power, because the thing is, Bitcoin actually uses 53 terawatt power per month, which is enough to like power, I guess, 5 million houses, or the entire country of New Zealand, or that's why so many people actually are against proof of work, because it is not clean. It uses so much energy. It is not really the best. It is very interesting to keep the security of the network, but it's not really the most ideal idea. Anyway, so you might be wondering, are there any other ways so we can achieve this consensus? Because we said, proof of work requires so much energy, and this might not be ideal for you, because you might develop a blockchain network, you might want to develop a decentralized app, because these ideas are actually used in decentralized applications. Anything that is labeled decentralized would actually kind of have to use a consensus algorithm, because again, remember that we have to reach an agreement on what is true. We don't know each other. Anyone can join the network at any time, so we have to actually verify this. So anyway, we talked about proof of work. I'm gonna walk you, very briefly through most of these. So proof of stake. Proof of stake is very different than proof of work, because now you're no longer a miner, you're a validator. And you have to have an enough stake of your money. What does that mean? So this is let's suppose we have a network, let's call it stake, whatever. And then in order for you to be a validator, you have to have some money that you lock into the network. You cannot spend it. If you spend it, you're no longer going to be a validator. So you're basically risking your money just so that you can actually earn money on the transaction fees. And so basically what happens here is that I will give some money of mine and lock it, and then I'll become a validator. This is interesting, but it has its drawbacks, because in proof of stake, theoretically speaking, you can actually just create multiple forks, and you can kind of really not really reach any consensus whatsoever. And then we have something else, proof of delegated stake. By the way, so many decentralized applications use proof of delegated stake. I used it multiple times in applications, and the idea of it is basically, all right, so what if I have so much money in the network, but I really don't want to, and I don't really want to be a validator. I don't care, but I care about the network. Like, you know what I mean? Like, I don't want to use my node or my computer to be a validator, but I still care about the security of the network. So I elect someone. I go and give them the value of my money. I'm not giving them my money. I'm just giving them the value of my money. It's kind of like a voting system where the money of your voters is really what's important. So imagine you're going to the elections, and they say, oh, okay, so the president of India or the US is elected based on how rich the people who elected him are. Anyway, you have a council of people, and so the way the validator, because obviously not all of them validate all blocks, because that makes the throughput really low and makes validating very slow. Some people use round robin, or just to make it simple, it's picked randomly. All right, so we have something very interesting. I'm not sure, I want to ask you guys if anyone knows what proof of storage or proof of space is, because it's very popular right now. All right, so did any of you hear about the network Shia? All right, so you are somehow familiar with proof of storage. So proof of storage, again, tries to solve one of the problems with proof of work, and it goes and says, we're going to use your hard disk. And you might be wondering, like, how are you going to use my hard disk? Are you just going to store the data? Not really. what it does is, yes, it uses plot. So what it does is basically, now remember in proof of work you were a miner, in proof of stake you were a validator, now you're a farmer. So what happens is you use a software, and this software plants or seeds some plots on your computer, and those plots can basically be cryptographically generated numbers. And here's what happens. When the person who gets to farm the new block would be the person who has the number that is closest to the challenge. So in each block, there is a challenge. The challenge is a number, and you know, if you have a number that is that number or very close to it, the closest number to it, then you get the reward. You're the one who validated the block, and yeah. So basically, just because I explained it in very broad terms, just related to proof of work. In proof of work, you're presented with a challenge and you have to solve it, technically by using your computer, okay? So using your CPU, your GPU, whatever, and technically you did not have the solution ready. The computer, not technically, you didn't have the solution ready. And then you had to do some work. That's why it's called proof of work. But proof of storage is basically the larger space you allocate to Shia or whatever network is using proof of space, then you're golden. Like if you allocate 1 terabyte or 10 terabyte, that means your probability of mining or probability of farming is really high. All right, so we move on to some, in my own opinion, really strange consensus algorithms. So proof of authority. Proof of authority is really weird because what happens is that I come out, I say, my name is Ihab McShea, and I am, this is my node, this is my computer, and yeah, and I will mine your blocks. So technically, you know, it might be a good way in some systems. Like you're just like, the only thing that would prevent me from corrupting the network is that my reputation would go bad and I will no longer be a validator. But yeah, then we have something called proof of importance. And proof of importance is basically, you know, you could say like it's a twist on proof of stake. So in proof of stake, you just had to allocate money and lock it, and then you could validate blocks. But in proof of importance, it does something else. It goes like, yeah, you have so much money in the network, but how much are you contributing to the ecosystem? Is the money going out of your account and coming into your account? Are you doing transactions? How important are you in the network? So it kind of does something very interesting because it keeps the ecosystem of the network going. And, you know, because proof of stake, if you think about it, it's kind of very simple. And then you have something as ridiculous as proof of burn. Proof of burn, the idea is really basic. In order for you to have a chance to mine the next block, you have to burn some of your money, literally burn it, as in, obviously not literally, because you have to send it to a burn address. And in order for you to know what a burn address is, it's just an address that no one owns. It's an account that no one has access to, and no one can have access to. So this money could be of the network's native coin, or it could be a foreign coin like Bitcoin. If you're into that, do not burn Bitcoins. They're very limited, and it's not good. So proof of activity. This is actually kind of complicated. It's a combination of proof of work and proof of stake. So what happens is your computer will do, you know, okay, so there are two miners, a miner and a validator. The miner uses proof of work to generate a block, an empty block, and then the validator will put the transactions in that block. And it's kind of interesting. It has so many use cases, but you know, let's get to some very complicated ones. So we have something called practical Byzantine fault tolerance. And this one, what happens is you know, the nodes get sent a message. Use this message, okay, to with the current state of the network to determine whether this is a valid transaction or a valid piece of data or not. and then they send it to other nodes. And then, it depends on the totality of the decision. If all nodes agree, then great. This is a valid transaction. It's great. It had been verified. Or if not all nodes agree, then you have to reach a certain threshold. You might be wondering, what is that threshold? The threshold could be 51%, 66%. Some networks actually do 66%. If it passes that threshold, then great, this is a valid transaction. Some networks that use this is Hyperledger. Hyperledger is a fantastic blockchain implementation. It's more has a lot of research and has a lot of really interesting work. But anyway, so this was practical Byzantine fault tolerance. We have a twist on it: federated Byzantine fault tolerance. And 1 second before I move on, one of the features of practical Byzantine fault tolerance is that the transactions are fast. They have finality. So once they're verified by the nodes, it's just great and has a very high throughput. Federated Byzantine fault tolerance. So this takes the same old idea that we talked about, and what it does is just it says something like this. Okay, so we're 100 people. I know John. John knows Mike. Mike doesn't know me, but Mike knows Adam. Anyway, we all have someone mutual. So here's what we do. We break into groups that doesn't matter. They know each other or they're federated together, and they decide. And when they decide this is a valid transaction or not a valid transaction, they send it to other groups of nodes. And then what they do is use a mathematical equation or an algorithm to determine whether this actually was accepted or not, and was there someone who's common between all of these groups or not. And then we have delegated Byzantine fault tolerance. And maybe we might be wondering, okay, delegated, so it's like proof of delegated stake, right? Yes. So what happened is, in this case, we have something called keepers or keeper nodes. So, in proof of work, it was miners. Here, it's keepers. And, the regular nodes would elect them, okay? And they must have proper tools, and they must have a minimum stake of coins. So obviously, what happens is that they're selected randomly, and after they're elected, they're selected randomly to verify the blocks. And an example of someone who's using this is Neo on NEO. I'm not sure if you guys are familiar with it or not. If someone is, give us a shout out. All right. So, and then I'm gonna talk about one more, and then we're gonna move on. Directed acyclic graphs. This is very interesting. It's highly scalable. It's very fast. The blocks are not yes, IOTA, yes, great, and Nano, and a lot of other really interesting blockchains as well. So in directed acyclic graphs, what happens is that the blocks are mined in parallel. They're not mined consecutively. All right. So we talked about this. Yes. All right. So someone earlier, I think, was asking about how different blockchains are. There are public blockchains, there are private blockchains, there are blockchains with one ledger, blockchains with multiple ledgers, and the way the validation is different between all of them. It depends on what they want. We talked really kind of extensively for this hour about a lot of consensus methods. Okay, and so I want to move on to one of my favorite topics, and it's cryptonomics. Okay, so what exactly is cryptonomics? You're building a decentralized system, and in order for you to build this decentralized system, you kind of need to motivate people to use it. And you have to be able to design a system that has desired properties and has to have certain things that would make people use it. So anyway, I'm gonna stop here and tell you about a project that I helped build in the past. And because I think this will help you understand the concept of cryptonomics a little bit more. So we built something called decode. Unfortunately, it didn't make it, as an actual working product, but it has a lot of research going in it. So decode wanted to solve one of the problems in decentralized applications. So in decentralized applications, there is no central operator. The data does not get deleted. There is no one to enforce any kind of rules. So if we have a decentralized YouTube, someone could post harmful stuff. Someone can steal a video from you and earn money from it. So what do we do here? We have an SDK, and that SDK would actually do most of the work for us. So what does that SDK do? It kind of establishes a court, and that court gets presented with cases from all of those decentralized applications. I would say like, okay, so this person stole my content and he's earning money, he's monetizing from my content, and I want that money. So the decentralized application would have a function in it that would execute the decisions of the court. And so the court would have regular people, doesn't have really, doesn't have judges, it has a jury. And this jury would just vote and based on the evidence that both sides have submitted. And so you would be thinking, all right, cool. And why would anyone in their right mind care about this decision? Why would I go and be like, okay, yeah, sure, so Stephen stole your content, okay, cool, no, what do I care? And this is where cryptonomics comes into play, because I am motivating you to do this. Okay, so there is a token or a currency for that decentralized application, and if you vote right, or you were in the side that voted for the decision that won, you would actually get some of that token. It would be minted every week. So you might be wondering, okay, cool. So what would make me vote right? This would get me to vote because I'm going to get paid. Why would I vote right? And this is where something interesting. So we use cryptography in order to secure your votes because they're public and they're on the blockchain. So I would hide your votes, and then people don't really know that everyone would actually vote right. You know what I mean? Like, if you don't know what others are voting for, you're inclined to think like, I have to vote right so that I don't get penalized. So you don't only use incentives, you also use penalties, because obviously depending on the system, you have to kind of have a penalty. If someone acts in a bad way, you have to burn their coins, or mostly burn their coins, or at least you can just take those coins and give them to the winners, which is an interesting way, interesting idea, because at a certain point the tokens would actually expire or end. Right, so we're nearing the end. So I'm just going to talk about some of the use cases, and we'll move on with our Q&A. So the use cases are absolutely, you can say, unlimited. You can use it in medical records, because I'm not sure how the medical system works in all the countries here, but at least I know how they work in the US and in Canada. And when you go to a doctor, you need your records, and they need them to know your history. And sometimes those records might disappear, or someone would just modify your record wrong or something like that. A blockchain would be interesting because again, the data cannot be edited, at least not easily. And if you use a very popular blockchain to do this, you could actually achieve absolute immutability for the data. Insurance, same idea. And voting, which, by the way, is really, really, really complicated in general. But yeah, so we're going to talk about smart contracts and what exactly are smart contracts. So we've been talking about, yeah, sorry guys. One second. Sorry about the technical difficulty. All right. So smart contract, we've been talking about decentralized applications, right? Like, how do you write a decentralized application? Do you just write it in PHP, JavaScript, C#, whatever programming language, no, you use, yeah. So every time I get a call, that will happen. Okay, cool. So anyway, like you type it in, well, you can type it in any programming language, really. But the way the bytecode of that smart contract will be deployed to a network. It could be Bitcoin, it could be Ethereum, it could be Hyperledger, it could be a lot of them. For Ethereum, it uses Solidity. Honestly, this is where most of my experience comes from. And again, not to exclude anyone, the meaning of bytecode just means compiled code, or meaning that I wrote the program and now it can run. Okay, so think of it as the EXE of programs. So when you get a program, you don't get source code. Obviously, you get something that you can run. Anyway, so and if anyone is following up, they will notice something. If the bytecode is stored on the blockchain, does that mean that I can do edits to the program at any moment? No, not really. There are ways to do something else, but if you're going to do a decentralized application, you kind of have to think of migration policies. All right. And migration policies are basically like, if at some point something is going to change, I want to change the logic, then I'm going to deploy another smart contract. In order for me to the people use that smart contract, it gets complicated. You do voting, you could do a bunch of other things so that you can actually migrate your logic into another smart contract. Smart contracts are a really great way of enforcing rules. Like, say I want to work with someone named Mark, and I said, okay, so Mark, I will pay you your money if you give me my service, or a bunch of milestones. So Mark delivered the first milestone. He gives it to the smart contract, and when he gives it the smart contract, there's some way, obviously this is programmable, to verify that he delivered the right milestone. So the money gets released automatically. The money is not with me, it's not with him, it will be with him. It's with a smart contract. So think of it as a third party that's not really a third party. It's a very autonomous way of executing things. But that does not mean that smart contracts can only be contracts. They can do a whole bunch of things. It can be very simple, it could be very complicated. But yeah, so now I wanna actually invite you guys to take a chance on taking a blockchain and cryptocurrency e-degree. It is designed and absolutely curated just for you. It has a lot of interesting content. It has 7 structure modules. It will ask you and help you build 7 real-world projects. It has 267 lectures, 28 hours of high-quality video. It has exams and quizzes just to make sure that you're following up correctly. There's a certificate upon completion. If you want to work as a blockchain developer, there's support for the interview preparation. The curriculum is really task-driven, and the responses you're going to get are expert verified, and you're going to have the lifetime access to the e-degree. So you're not going to have to renew it every year. And if the curriculum is updated, you're going to get that update for free. So what exactly will you learn in this e-degree? You will learn about the ecosystem of blockchains, the things we talked about briefly today. You're gonna know what transactions are. You're gonna know the layers and the infrastructure of the blockchain. You're gonna know what peer-to-peer or P2P systems are. You're gonna know and understand more about Bitcoin and Bitcoin mining, Bitcoin networks and trading, double spending problem, which is really interesting. Ethereum and smart contracts. You're gonna learn how to program in Solidity. You're gonna know Hyperledger and Hyperledger Composer, which is another way to create smart contracts. You're gonna know how to create or interact with blockchain with JavaScript. Highly recommend. You're gonna understand more about multi-chains and creating private blockchains. So some of the projects that you're going to actually build with the blockchain and cryptocurrency e-degree, you're going to build a Bitcoin trading application, or you're going to learn how to do Bitcoin trading on various trading applications. You're going to trade with multiple cryptocurrencies. You're going to learn how to use Bitcoin Core for Bitcoin mining. You're going to do a business network application using Hyperledger Composer. You're going to implement blockchain transactions. Okay, so this actually goes for a special offer only for 24 hours for a flat $31 for a lifetime access to this course. We can start the Q&A now, but let me remind you guys that this session was about the technology of blockchain, why the blockchain is interesting. I tried not to mention networks by name, except for examples and stuff, but did not want to get deep into Bitcoin or IOTA or Nano or Ethereum or any of those, because there are two parts of this. There's a part about learning the concept or the development of blockchains, and there's the trading and mining and all of that. I'm not a financial expert, so if I said some criticism of a network, that does not mean you should not buy it. If I endorsed one of them, that does not mean that you should invest in it. You should ask someone who is absolutely an expert at this, and that is not me. But questions about the blockchain technology, far away. All right, so we're starting with quantum computers for blockchain. Can they hack the blockchain? That's a very interesting question. That is actually a very interesting question. So yeah, this would be actually somehow a criticism of proof of work. But I wouldn't think so. I don't actually understand quantum computers very well because that's not really my area of expertise. But if they actually, if they can, that is going to be a yeah, I was muted somehow. All right. So someone was asking about Oracle. So quickly, an Oracle is just a way for blockchains and smart contracts to interact with external data. If you're a developer, you know our APIs. So oracles are a way of it's like an API layer, which the smart contract itself is an API, but oracles just interact with the outside world. They communicate data that needs to be, it's needed for the closed blockchain, like the weather today, because some people use blockchain for betting. So in that case, you would need an oracle. You would say like, oh, if Barcelona wins, then this person gets $100 or gets everyone else's money. So this cannot really be integrated directly into the blockchain. It needs to be coming out of an external source of data. Okay. I don't think the e-degree will actually cover AWS or blockchain as a service. I don't think so. Is the proof of stake more centralized? Look, if things are not implemented perfectly or implemented the right way, they all can be centralized. Proof of work, there is a lot of criticism of Bitcoin currently because remember earlier we talked about how Satoshi Nakamoto made mining really hard in Bitcoin, and there is a very interesting point to that and very valid point. But then computers had to start mining pools. So you have to join the mining pool to mine, and mostly, not mostly, definitely, people who mine Bitcoin now are mining pools. So technically, this is centralized. And like, if a country decides tomorrow morning that they're going to dedicate, I don't know, like 1 million computers, and those 1 million computers will mine Bitcoin, then absolutely, it's going to be centralized. To answer your question specifically, is proof of stake more centralized? Yes and no. you know, so yeah, it's yes and no, all right? And because yes, it depends on the money and all of that, but at the same time, more people can join in. All right, so I'm gonna take 1 minute and come back.
So hello everyone. Am I audible to you all? Okay, thank you. So guys, it was lovely to hear from Ihab and to understand the concepts of blockchain and how the cryptocurrency works in general. So as due to time constraints, we won't be able to take this Q&A session long as I respecting everyone's time. So I will just quickly present my screen, share my screen, and I'll talk about the e-degree and the offer which I was talking about at the earlier of the session. So yeah, once again, thank you so much for this lovely session. It was nice to hear you.
Thank you so much. Yeah.
Yeah, yeah. So guys,
Thanks
let me know.
everyone. This was really great.
So guys, let me know whether my screen is visible or not. Okay, Ashish, thank you. So guys, here are the few things I thought I will share on screen and via PPT. So, and I will tell you some key points that at Eduonix, guys, we have our own e-degree on blockchain. And the name of this e-degree is Blockchain and Cryptocurrency e-degree. And it is exclusively like curated for you all guys. As you can see on my screen, there are few key points and why should you go for this e-degree and not for other e-degrees which are out there. So guys, we are giving out 7 real life projects. We have 7 structured models. So it will be gonna be a 267 lectures with 24 hours high quality videos, guys. To measure your progress, we are giving out some quizzes in between. We are conducting some exams, guys. And upon completion of this e-degree, we will be giving out some certificates. And these certificates are will be industry accepted. So you can, so these certificates will really, really help you. We are also going to have one interview preparations session. So in that, you are gonna get support for that. So these are the points, guys, which we have also already talked on. So so yeah, guys. So these are the points which you can see on my screen are the technologies or the topics which you are gonna learn. So you're gonna learn blockchain ecosystem, how the ecosystem works, and Bitcoin networks, how to mine Bitcoins and to peer-to-peer systems. So yeah, guys, we are also be going to cover few real life projects so that you can have your hands-on experience with the how to engage in this thing. So these are the few projects we have on the screen, like Bitcoin trading on various trading apps. So you are gonna learn that. So guys, before I'll just tell you about the offer. Let me know, guys, who all are interested in this e-degree and planning for uh, opting this e-degree and getting yourself a certified in this technology, guys. Anyone is there who's interested? Okay, another I'm interested. Rajesh is saying he's interested. Okay, nice, nice, nice. That's a really good. So I'll just quickly show you the offer. So guys, this is the offer. We are giving out our blockchain and cryptocurrency e-degree flat at $31, guys. And this is a rock bottom price. We are also be sharing the link on the chat box, guys. Please let us know whether this link is working or not. Okay. So our team member has just shared the link. Please let us know whether this link is working or not. Also, guys, this offer, I would like to tell that it's only be gonna valid for next 24 hours. So please think on this offer and do avail this offer. Okay. So before we end our session, I would like to talk about feedback, guys. So your feedback is really, really important for us. And do share your valuable feedback, guys, with us, and do let us know how we can make our session more interesting and more fun for you all. Okay, I will just quickly share the link of the feedback. Okay, uh, guys, after this session we will be giving out emails, and in these emails will consist of offer link as well as the feedback link. So those who have missed the link, so no need to worry about the links. And yeah, so by saying that, I will once again paste both the links, and by saying that, we will just end our session. And I would like to thank Ihab and all of you for joining in and making this session such an amazing one. So thank you so much, guys. Have a nice day ahead. Bye bye. Thank you so much.
Thank you everyone for coming today. It was a pleasure, and I hope to see some of you again. Bye bye.
Thank you. Yeah. Bye bye.